Okay, so we're going to start with sequences today. And when we have sequences, we always want to look for the patterns. Do we have a first difference, a second difference? Is there multiplication going on, division? So always look and see what the pattern is going to be. So this first one wants me to write the first 4 terms of the sequence. So we're going to start by finding the first term. So all we're doing is plugging 1 in for n. So I'm also going to plug it in into the equation part. So the first term would give me 2 to the 0, which is 2. Well, let's do the second term. So that'd be 2 to the 2 minus 1, which is going to be 2 to the first, which is 2. Oh my gosh, so sorry. This one, 2 to the 0. Anything to the 0 is 1. I'm sure you guys are like, Doris, come on. All right, so let's do the next one. A sub 3 would be 2 to the 3 minus 1, which would be 2 squared, which is 4. And are you just seeing a pattern over here of what's going on? It looks like we're just multiplying by 2. Let's see if that works. It sure did. So our first 4 terms are 1, 2, 4, and 8. All right. For this sequence, we're going to describe the pattern and write a rule for the nth term. So 3, 6, 9, 12, what's going on? We are adding, whoa. Oh my gosh. All right, we'll go from here. So we are adding 3 each time. So if I wanted to write the pattern of what's going on, we could think that this is my first term, my second term, my third term, and my fourth term. So to get to a general term, what do I need to do? Well, I'm going to take the previous term and add 3. Now, just a general rule, if you don't know what the previous term is, then we're going to have to say that if I know for any n, what am I going to do to n in order to get out 3? So if n is 1 here, what do I do to 1 to get out 3? Well, I multiply it by 3. So n times 3. Well, let's see if that works for the next one. If our n is 2, 2 times 3 is 6. When our n is 3, 3 times 3 is 9. And when our n is 4, 4 times 3 is 12. So these are 2 different ways. This is a general rule. This works. However, it's you have to know the previous term in order to apply it. Now, the way you're going to see this a lot on the EOC is they're going to use next and now. So they're going to put that the next term would be equal to the now plus the 3. So just a little bit different way of writing it. All right, look at that next one. See what you would do. Good. So you are multiplying by 3. So how can I write that? Well, I could take a sub n, and I could take the previous term and multiply it by 3. But we have to know the previous term for this one. So how could I write it where all I know was n? So again, if this is my a sub 1, this is my a sub 2, my a sub 3, my a sub 4, and n is 1, 2, 3, and 4, what would I have to do to 1 in order to get this out? So some of you guys may remember, if you're doing the multiplication, that you have this power rule going on. So it'd be 3 to the n. So here, 3 to the first is 3. 3 to the second is 9. 3 cubed, 27. 3 to the fourth, 81. And again, if we're doing the next now, then the next would be equal to 3 times the now. Okay, this next one's a little bit trickier. We've got some fractions going on. And you can see that the fractions, you add 2 in the denominator. So to give you the previous next, it's a little bit harder. So we're going to jump over here to the, just if we have the n term, how could we write this equation? Well, I always have 1 in the numerator. And then what about the denominator? Do I want 2 to the n? 2 to the first be 2. 2 squared, well that's 4. 2 cubed, is that 6? Nope, so you don't want 2 to the n. So if I have a constant difference, that tells me that I have a slope of 2. So it'd be 2 times n. All right, next now is what we're kind of talking about. So if you saw the pattern of 2, 4, 6, 8, and the first now is the 2, then you can write, to get to that next part, the 2, the now plus the 2, when you see the pattern of adding 2. All right, so let's see. If the first now is -3, then we're going to do parts A, B, and C. So the first now is -3 in all of these, and I want to write a next now equation for these. So I'm going to start with the next equals, and what do we do to -3 in order to get -6? And then what do we do to -6 to get -12? So we multiply by 2. So I'm going to take 2 times the now. So you can think, well, what's 2 times -3? -6. Good. What's 2 times -6? -12, etc., etc. Okay, let's look at this next one. How do I get from -3 to 9? What do I do to 9 to get 81? And what do I do to 81 to get 6561? All right, so let's see. Maybe some of you are trying to add or subtract or multiply. But here I can see, well, -3 squared is 9. 9 squared is 81. And 81 squared is 6,561. So what do? We take the now and we square it. All right, let's look at this last one, part C. So what are you doing here? Any ideas? So what happens if I take -3 and multiply by 2? Well, that's not quite -5, but it's really, really close. Well, what happens if I take -5 and multiply by 2? I'm at -10. Let's see, what happens if I take the -9 and multiply by 2? It seems like each time I do that, I'm underestimating by 1, going 1 lower than what I had. So let's see, if I take the now and multiply by 2, then I would have to add 1 to get to the next term. Okay, we're also going to do 9.1. we're going to do some distance and midpoint. So the distance and midpoint formula, distance just comes from the Pythagorean theorem. So look over here at this triangle. Okay? So if I knew x1, y1, and a point x2, y2, I know those 2 points. Well, this would be where the x2 was, and this would be where the x1 was. So if I want to know what this amount was, think if this was 5 and this is 3, what would the amount of that line be? That distance would be 2. And the way you did that was 5 minus 3. So we're going to do, in general, x2 minus x1. Same thing, if this was y2 and this is the y1 part, and let's say y2 was just like 6 and y1 was 1, well, how would you get this length? You would take 6 minus 1. Well, in general, we're going to take y2 minus y1. That's for any point that you have. All right, so if I have that this general length, get rid of those scenarios, if this general length is x squared minus, x sub 2 minus x sub 1, I know Pythagorean theorem says I'm going to take that distance plus y sub 2 minus y sub 1, that distance, both of those squared, and set it equal to the hypotenuse squared. And then to solve, I have to get rid of this square with the d, the hypotenuse, so I would have to square root plus or minus to get rid of the square. However, since distance can only be positive, I'm only going to take the positive of this. And that's how you get the distance formula. The midpoint formula is just the middle. So it's the middle of the x's. So if you had an x of negative 5 and an x of negative 1, well, where's the middle? The middle is right here in between at negative 3. So if you had a y at 1 and so a y at 1, this is not my lucky day, and a y at 6, so what's the middle of those two? It's at 7/2. And you can do that by saying 1 plus 6 and divide by 2. So you're just taking the middle of them, the average. So what's the distance between these 2 points? So I'm going to first label x1, y1, x2, y2, and set up my formula. And now I can simplify this. And can I reduce 85? Do any perfect squares go into 85? So 4 doesn't, 9 doesn't, 16 doesn't, this 25, nope. So keep looking through. None of those guys are going to go into it. So you can leave it the square root of 85. All right, so we're going to classify triangles as scaling, isosceles, or equilateral. And you have to remember, scaling means no equal sides. Isosceles means 2 equal sides. And equilateral means 3 equal sides. So how do we know what the sides are? Well, let's look. What if I wanted to find, let's do side AB first. So side AB, I'm going to have to apply the distance formula to see what that length is. square root of 18. This does simplify because that's the square root of 9 times the square root of 2, which is 3 radical 2. All right, what do you want to do next? How about BC? See if you can fill that in. And I got the square root of 29. Well, we can definitely throw out the equilateral here because these two sides are not equal. So let's go find the last one, AC. And I got this to also be the square root of 29. So this tells me that the triangle is an isosceles triangle. Two equal sides. Woo. Right, ready to do one more. This funky way the PowerPoint is running on us. Midpoint. So find the midpoint between these two sets of coordinates. So remember, midpoint is just the average. To average, I add the x's, divide by 2, add the y's, divide by 2. Reduce that. And I get -3 and 7/2 is right in the middle between those 2 points. Okay, try the next one. See what you get. Check it with your group members when you come in tomorrow. And if you want a little bit harder, you can try these. I know that they're not written on your notes, but I could definitely still ask you some questions like this. I would really like you to see if you could figure this out. And then come into class tomorrow and see what your group members say. I'll also help you too if you need it. All right, I'll see you in class.